Okay, so we're now beginning chapter 22, the respiratory system. We're going to talk about, the rate and the depth of breathing. We're going to see how breathing is clinically significant, and we're going to talk about the exchange of the gases that occurs with the respiratory system. The functions of the respiratory system are gas exchange, for us to be able to exchange oxygen and carbon dioxide, voice production because of the movement of the air past the vocal folds, olfaction because of airborne molecules that are drawn into the nasal cavity, the regulation of pH because of the ability of the system to eliminate carbon dioxide, the regulation of blood pressure because this system synthesizes angiotensin II, and we're going to see how this system helps with blood flow and the flow of our lymph, because breathing creates pressure gradients. We're going to find that in the functions, breathing is termed respiration. And these four processes right here, ventilation, external respiration, transport, and internal respiration, these are all the functions of respiration with our lungs. Ventilation is a term for movement of air that can go in and out of our lungs. Now, in respiration for the lungs, we're going to say that we have external respiration and internal respiration. External respiration is the gas exchange between air in our lungs and the blood that has contact with our lungs. Internal respiration is going to be the gas exchange that we have between our blood and that extracellular fluid of the tissues. In the transportation for the respiratory system, we're moving oxygen and carbon dioxide that will be found in the blood. When looking at the structure of the respiratory system, we're going to say that we have an upper respiratory tract and a lower respiratory tract. We're going to say that we have what's termed our conducting zone, basically air going into our nose, moving into those bronchioles. And then we're going to have a respiratory zone where within the lungs, we're going to see the gas exchange between the air and the blood. In our upper respiratory system, in this upper tract, it's going to include the nose, the nasal cavity, the pharynx, associated structures with the pharynx, and our larynx. The lower tract is going to be our trachea, the bronchi, smaller bronchioles, and then into our lungs. When we look at these areas of the respiratory system, the nose and the nasal cavities, one of the reasons that this is so important is in the structure that we have for the nasal cavity, we're going to see that we have these three little flaps that are right here. These flaps are called choanae. And what they're going to do is, as air comes in, because air we're going to need to warm and moisten the air because air that comes in, most likely it's not going to be 98.6. So the air will move into the nose. These choanae will create turbulence, and then for the air to pass through the rest of the respiratory system and make it to the lungs, this area hopefully will warm the air and moisten the air so that it's roughly the 98.6 going into our lungs. Now, in the area of our pharynx, we do have what we see, some special structure showing up, the pseudostratified columnar epithelium with goblet cells. In this area, we're going to see that we're going to get air from our nasal cavity. In the area of the pharynx, we're going to also see that it's going to be receiving food and drink for our oral cavity. Because of this structure and the lining that is created, we're creating mucus, and what this is going to do, it's going to help trap any debris that will try to make it into the system for our breathing. As we look at the larynx, it's a special structure. It is going to be the area that we're going to find our vocal cords. It has some very interesting cartilage, especially the cartilage that makes up the Adam's apple. The cartilage is going to have some very interesting structure to it. We're going to find that the larynx is also lined with the pseudostratified ciliated columnar epithelium with the mucus lining, because we're going to find that once again we're trying to trap debris and keep it out of getting into the lungs. As we move into the trachea being this really long tube, we're going to see that it has a very interesting structure. If we look at the cross section, we're going to have this hyaline that looks like it's in the shape of a C, and then it has a muscular portion. Well, the muscular portion is going to be for the digestive system, and this allows for the passage of food going into the stomach. The lining is once again pseudostratified columnar epithelium. In this long tube, it's going to have this mucus lining, and it helps to trap the debris and push it upward to try to keep it from getting into the system. Now, this lining that we get that comes to us from the pseudostratified columnar epithelium with the cilia, those goblet cells that are producing the mucus. I am sorry, guys, something is going crazy in my driveway and I don't know what. The goblet cells are producing the mucus. Their job is to trap the foreign particles, and then for the cilia, for them as they're moving, to take that foreign particle that might be trying to get into our lungs, push it up towards the larynx, the pharynx, and eventually in some way, like we cough or we clear our throat, something to that number, and we begin to move that foreign debris out. Now, this epithelium that is being created right here, with this epithelium, when it becomes, what happens with like smoker's cough, for example, rather than it being the nice pseudostratified columnar epithelium with the goblet cells, it actually becomes stratified squamous with no cilia, and therefore you cannot move any of the particles that are trying to enter into the lungs out. And it's the reason that people get smoker's cough, because the smoke and the nicotine and everything have made these cilia just bend over and basically die. But now remember, this can come from smoking anything, because those chemicals get onto these tissues and they eventually turn into the squamous epithelium. Now, if we begin to look as the trachea begins to move downward, and we have the two branches, and we get into this area of the bronchi, that covering for the mucus production, it actually goes all the way down to this region. And the goal is to be pushing debris out before anything can make it into the lungs. Now, with the structure of our lungs, the base of the lungs sits on the diaphragm, the apex, of course, here at the inferior portion. We have an area that's termed the hilum. This is where blood vessels and so forth are going to enter. We're going to see that branching begins to occur. On the left side, there are 2 lobes of the lung. On the right, there are 3. So we're going to have our main bronchi leading into primary bronchi, leading into secondary. So you would have 1, 2, 3. On this side, it would be 1 branch, a second branch, and then we get into tertiary branches, where we begin to see branching into the lung. And as that branching continues, we eventually end up with about 7 generations of branching until we get to this area of the alveolar sac. The alveolar sac is connected to a duct. We have that connected to terminal bronchioles, which meet respiratory bronchioles. Now, at this point, we can see that these alveoli have a connection to capillaries. They are very well vascularized, and because this is going to be the area where everything occurs, this is where we're going to get to see the exchange of our gases, the exchange for the oxygen and the CO2. In our lungs as a whole, we're going to have about 3 million of these alveoli throughout our lungs. One thing about this area, the tissue is very elastic, and this is going to allow for expansion and recoil that can occur in the lungs for ventilation, for the respiration, the air to move in and move out.